Welcome to Laws of Indices Level 2. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 4y to the power of 3 multiplied by 5y to the power of 6 all over 2y to the power of 4. Since we're multiplying in the numerator, we're going to use this law, which tells us that when we multiply indices together, we add the powers. So on the numerator, we're going to start with 4 times 5, which is 20, and y to the power of 3 multiplied by y to the power of 6 is y to the power of 3 plus 6. Simplifying that numerator, 3 plus 6 is 9, so we have 20y to the power of 9, and our denominator remains as 2y to the power of 4. Now this fraction line means we're dividing, and since we're dividing indices together, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 20 divided by 2, we have 10. Y to the power of 9 divided by y to the power of 4 is y to the power of 9 minus 4 using our law. And since 9 minus 4 is 5, our final answer to problem 1 is 10y to the power of 5. In problem 2, we're evaluating 4 to the power of minus 2, which means we need to find its value. Since we have a negative power here, we're going to use this law, which allows us to rewrite 4 to the power of minus 2 as 1 over 4 to the power of 2. And since 4 to the power of 2 is 16, we have 1 over 16, or 1/16th, as our final answer. In problem 3, we're simplifying 2t to the power of 8, u to the power of minus 3, all raised to the power of 4. Since we're raising powers to powers here, we're going to use this law, which tells us that when we raise a power to another power, we multiply the two powers together. Before we start multiplying, we first have to realise that the 2 at the start of the bracket has a power of 1 on it. Now we've done that, we can start multiplying our powers together. So starting with 1 times 4, we have 2 to the power of 4, followed by 8 times 4, that gives us t to the power of 32, and finally minus 3 times 4 gives us u to the power of minus 12. Now since 2 to the power of 4 is 2 times 2 times 2 times 2, that becomes 16, and so our final answer here is 16t to the power of 32, u to the power of minus 12. In problem 4, we're evaluating 2/3 to the power of 3, which means we need to find its value. Now to start, it's important we rewrite 2/3 as 2 to the power of 1 over 3 to the power of 1, all raised to the power of 3. And it's important because it now becomes clear that this problem requires raising powers to powers. And because of that, we're going to use this law, which tells us that when we raise a power to another power, we multiply the two together. So applying that law here, we can start by multiplying together 1 and 3, which gives us 3. So our numerator becomes 2 to the power of 3. Similarly, in our denominator, 1 times 3 is 3, so our denominator becomes 3 to the power of 3. Now since 2 cubed is 8, and 3 cubed is 27, we have our final answer, which is 8 over 27. In problem 5, we're told that f to the power of 5 multiplied by f to the power of n all over f to the power of 10 is equal to f to the power of 6, and we're asked to find the value of n. Starting with the left-hand side and looking at the numerator, we're multiplying indices together. So to do this, we use this law, which tells us that when we multiply indices together, we add the powers. So the numerator becomes f to the power of 5 plus n. That's all over f to the power of 10, and it's equal to f to the power of 6. Now the fraction on the left-hand side of the equation means that we're dividing f to the power of 5 plus n by f to the power of 10. And since we're dividing indices here, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So the left-hand side of the equation now becomes f to the power of 5 plus n minus 10, using our law. And that's equal to f to the power of 6. If we simplify the left-hand side, we have f to the power of n, and 5 minus 10 is minus 5. So n minus 5 is equal to f to the power of 6. Now, since the left and the right-hand side of this equation are equal to each other, and since they have the same base, which is f, this tells us that their powers must also be equal to each other. And so we can write that n minus 5 is equal to 6. Solving this equation by adding 5 to both sides tells us that n is equal to 6 plus 5, which is 11. And that's the answer to problem 5.